Hello, my name is Pablo Gugel. I'm an environmental designer at Atelier 10, and the topic of my paper is assessing the use of UTCI in semi-outdoor spaces, based on a case study in Hyderabad, India. Hyderabad features a tropical climate with a summer season that goes from March to October. The first part of the summer, from March to June, is a hot, dry season with temperatures that can go up to 45 degrees. And a second part, which is June to October, that corresponds to the monsoon, with warm temperatures from 35 to 20 and high relative humidity due to heavy rainfall. The building is a 20-story office building that features a 10-story semi-outdoor light well. This light well features a number of transitional spaces that connect the outdoor environment through a shaded atrium into the light well, which is connecting by a number of lifts the semi-outdoor galleries and then into a conditioned office space. The light well is provided with a number of environmental strategies that were tested using UTCI methodology. The first one is simple solar shading. Then the second option would be solar shading combined with ceiling fans, and option 3 is solar shading, ceiling fans, and water misters. UTCI methodology, which is a scientifically developed tool that hasn't been included in international standards, was used for this analysis. It captures environmental factors such as air movement, humidity, activity level, solar radiation, air temperature, and clothing. And the results of this calculation are expressed in 10 different color bands, which go from extreme heat stress to extreme cold stress. This methodology has a number of known limitations. The first one is that it doesn't understand space as a sitting or resting area because there's a fixed walking activity of 1.1 meters per second. The second one is it doesn't capture time as a factor for thermal comfort adaptation. It is difficult to incorporate the effect of radiation of hot surfaces, and it doesn't adequately understand complex air movement that could be tested using CFD. The calculation was used using a bespoke Ladybug and Honeybee script, using waterfall from NACPO, using the summer period from March to October. 4 different scenarios were tested: full exposed, solar shading with air movement from fans, and solar shading with air movements from fans and water misters. Full exposed scenario was tested, and the UTCI was represented in this diagram with the horizontal axis showing the months and on the vertical axis showing the hours of the day. You can see that during the hot dry period, extreme heat stress happens quite regularly, and during the warm humid period, very strong and strong heat stress happens quite regularly during occupied hours. With the incorporation of solar radiation, extreme heat stress disappears, and very strong and strong heat stress gets reduced during the warm and humid period. Solar shading proves to be a very efficient tool in this kind of climate. With incorporation of air movement from ceiling fans, the very strong heat stress and strong heat stress gets reduced during the warm and humid period, during the monsoon period. And the incorporation of water misters substantially reduce strong heat stress across the whole year. The client was particularly concerned about Legionella, so this strategy was not implemented. Because solar shading was particularly useful, we decided to analyze sunlight hours in a bit more detail across each of the different floor levels of those galleries, with an intention of reducing average sunlight hours below 1 hour on average. The image on the left shows the light well and how sunlight hours are affecting the east and west facades more regularly. So the architect decided to propose the solar shading represented on the right, which was quite uniform across all the orientations and without any difference between the lower and upper levels. So with our input, the density of shading was increased in the east and west facades, and from the upper levels to the lower levels. And then we refined it further by eliminating the triangle oculus on the upper levels. And the results of these improvements meant that the sunlight towers was reduced across levels 21 and 20, which are the most exposed, to less than 1 hour on average in most of the surfaces. Thank you.